Hello, Gapsters. I'm thrilled to welcome you all today to the Data and AI Fest, the first GAP event of the year. We're putting together an exciting schedule full of learning and knowledge for all of you. Today, we have the pleasure of having with us Dr. Tomás de Camino. He is the director of the School of Intelligent Systems of Sempotech University. He holds a PhD in mathematical biology from the University of Alberta in Canada, master's degree in computer science from the Instituto Tecnológico de Costa Rica, and a bachelor's degree in biology from Universidad de Costa Rica. He also holds postdoctorates from the University of Alberta and Penn State University in mathematical and statistical modeling of biological phenomena. He was the founder and director of the Costa Rica Foundation for Innovation and the founder and director of the Research Center for Innovation at Veritas University. He's an innovation manager certified by the Ministry of Technology in Costa Rica. In 2020, he received the Wolfram Innovators Award for his work in computer models. And in 2008, the Springer Lee Siegel Award for his contribution to mathematical biology. In this talk, Dr. Tomás will address the topic of generative artificial intelligence, illustrating through concrete examples of professionals in various disciplines and narrating personal experiences and how it leads us to a new era. Thank you, Doctor, for your visit to GAP today and the festival. We know we are all eager to hear your insights, so the stage is yours.
Thank you very much, Ivan. It's a great pleasure to be here with you guys. And well, we're kind of in a very interesting era of computer science and computation and software. Imagine when I learned to program really young. I was 10 years old when my dad gave me a Sinclair ZX81, which was a 1 kilobyte memory computer. You had to program this in using BASIC, and it was structured BASIC with line numbers and such. And imagine like that was not so long ago. Well, I would hope it's not that long ago because I don't feel that old, but so many things have happened since then, and we're moving. And I mentioned this because we're moving. When I was programming BASIC, there was a reason why I would need to program using something like BASIC, that computer. But nowadays, we have moved to something else. And in particular, when we mean software, building software, it means something completely different. So I want to sort of give an introduction of artificial intelligence, talk a little bit about generative artificial intelligence, in particular ChatGPT, and then through some examples that I have done on my own and some others that I've from colleagues, perhaps think about what all this is going to mean for people working in programming or people developing software and so on and so forth. So I called it, my slides are going to be in Spanish, but I'll be giving clearly the talk in English, but my slides are going to be in Spanish, so it's going to be, I guess, the best of both worlds. I don't use a lot of text in my slides anyway, so it's not going to be that hard to infer what I'm actually doing and saying. So let's start with artificial intelligence. I think most of you are from the area of computation informatics or something like that. So I won't go into details about this. We can talk about it perhaps at the end if you have questions. But the simplest definition is basically that artificial intelligence is computers that normally do tasks that normally humans would do, right? Although that's a broad kind of definition. There is something more into it. Like if you think, for example, Excel. Well, Excel is actually doing some things that a human would normally do. Say, for example, a pivot table or some graphics or things like that. But the difference has to do with the following. And imagine we have basically a box, and when I'm saying that it's a computer doing what normally humans would do, imagine we have data coming in, as we ourselves are sort of information machines. We receive information through our senses. A computer receives data in some form, and then after some processing or some functions applied, it just does something that we call a human action. And it does it not by programming it directly, because some life, some other organisms, not human, also sort of receive information and do operations, but that doesn't mean they're intelligent. For example, plants, the leaves can move because of orienting themselves to the sun. That doesn't mean that the leaves are intelligent, but the difference of intelligence perhaps comes from this, but the fact that there is some training, that the function that they do, it's due to they've been through some training, some information, and with that, they sort of infer some sort of task that they have to do. So once you train this system, this sort of box, then when you feed them data, it's going to do some sort of prediction. So artificial intelligence is nothing but a prediction machine, something that is just doing prediction based on some training and using some data that it's fed. And then based on that, it's used for making decisions. So, for example, something like Netflix, when a recommendation system like Netflix is basically, it's trained with all the people watching different movies. Then when you are watching your movies, that information is processed, and then some prediction of what type of movies I'll be watching is obtained, and then there is some decision made in terms of I'm gonna recommend these and these movies to Tomas, and that's when the action is done. So sometimes, most of the times, there is some it's not that it's just a decision made, but the system, artificial system, it's also can be retrained, or even be, while giving decisions, training in real time. And that's really useful. And that's I would say why we would kind of move a lot to using artificial intelligence system, because they don't have to be fixed. They can change, they can adapt, they can move with us at the same pace or even faster. And then for that reason, they're really, really useful, right? So in terms of the broader picture, it's funny, like we used to talk a lot about machine learning about 4 years ago. It was more about machine learning than artificial intelligence. And well, it turns out machine learning is just a subset of artificial intelligence. When we talk about artificial intelligence, we talk about the broader scope. We even think about machine thinking or behaving like humans. When we talk about machine learning, we specifically talk about algorithms that are applied, that use all these techniques of training and learning, and are applied to some specific tasks, like, for example, this recommendation system in Netflix. Then within machine learning, we talk about deep learning, and deep learning is specifically with lots and lots and lots of data, and most of the time where there is a unsupervised information, which means that I don't know exactly what patterns the data have. I just feed them to this algorithm, and then it tries to infer or try to tell us what type of patterns can be found. And from there on, well, we go to what's now becoming really popular, large language models that are not new, but are becoming really popular. And within that, also what's called generative AI. And furthermore, these generative AI are becoming what's called foundational models that I'll explain a little bit further. So you see, artificial intelligence is a really broad area and involves lots of things. And of course, anything that it's done by a computer I would speculate they would tend to be to use some sort of artificial intelligence mechanism inside, even though things that do very direct tasks, that even are within a set of problems that are closed and not so hard, they're going to be pushed to be done by some sort of artificial intelligence, by reasons that I'll explain a bit later. And the important thing is that this generative AI, including ChatGPT, are not just some smart chat that you can talk to. They're actually foundational models. What does that mean? That means that anything that can be done with artificial intelligence can be done with these models. And that's a really powerful concept, meaning that any artificial intelligence can be done with these generative AI machines. And that's why they're becoming so widespread, and people are finding ways of using these things in many different areas. So basically, when I say foundational model, what I'm talking is that you have some code that has to do with the training of the system. Then we have some data that it's either labeled or unlabeled, and this model just generates new content based on that information. And that content can be code, can be text, can be images, could be absolutely anything. So basically, you need to have some training that it's reasonable in terms of what you expect the machine to do, and then data by which it's trained to be able to create to generate new content. Sorry. So if you think of what traditional artificial intelligence or machine learning would do, I would have a specific task. I would create a specific AI model to solve for that task. For example, I've been working with some people in medicine, and they have the system to measure what's called the biological age, and then basically you train a machine learning algorithm to just be able to estimate that biological age, and that's about it. That algorithm that cannot do anything else but that. And then if you need to do a different task, then you have to then train or create a new model, a new system, and then do some training and so on and so forth. But then a foundational model, it's basically with the same artificial intelligence machine, you train doing all these things. All your tasks are fed up to this system, and then you refine them. So basically, something like Chat GPT, it's trained within a corpus that it's actually very large, and it involves um, most of what it's been digitalized, which is basically everything, all human knowledge and books and articles and forums and, well, GitHub and all those things. And then you can fine tune these models to do something more specific, right? Even though they've been trained with a really large corpus of knowledge, then you can refocus them and fine tune them to do something a lot more specific and precise. And so basically use the same model to do absolutely everything. And that's why they call foundational models, because within them they have everything that needs to be known basically to solve any task. That's kind of a big word to say for a model of artificial intelligence. That brings me to then generative AI. So basically, AI, it's basically a computer doing human task. Generative AI, it's the same artificial intelligence, but it generates new content, new information based on the information it was trained with. And then that's why it's called generative, because it generates something new. So basically, if you think of coding, then basically you can create a code for you. It will write a code, and that code, it's written, it's completely original. Although it's based on everyone's code pretty much, it's completely original, right? So if you ask for that code, and you have 3, 4, 5, 6 times, it may generate variations of that, but it's a different code, and it is completely original. It's not a copy paste of some code somewhere else, right? And imagine if usually when you would program something, and I don't know, I want to apply the Dijkstra algorithm or something like that, I would usually go to numerical recipes. Well, in my days, you would go to numerical recipes, then the algorithm, and then copy paste in the old ways, right? Which is transcribed in front of the book probably. But then now, after that, people would just get it somewhere in numerical recipes published somewhere in some GitHub probably, and then you would get to copy the code and paste it. That wouldn't if you use that code, it's not original code. You're just copy and pasting it from somewhere else. But when you do it with a generative AI system, it is original, right? Although, I mean, Dijkstra algorithm has certain structure and they may have variations, but you wouldn't expect it to be that different from any sort of implementation that we already know and seen. So that's important. Now, large language models and something like ChatGPT, it's not really that new. A big breakthrough was when the recurrent neural networks were thought, and that's basically a neural network that feeds itself the output it produces, right? So then it can recurrently generate more of what it's already been generating. So that's what the first approach, and there was something like long short-term memory machines that was the first approach. It was somewhat successful, but it was really slow, and it wasn't practical, and it doesn't have the power that we see in nowadays. Now something came out that an algorithm that it's called attention. It uses attention, and attention means that when a word, or you say you write a prompt, then one of the hard tasks of a computer is to pay attention to what exactly are you saying or what exactly are you asking, because you have put a bunch of words, but then there's something that has to be the focus of with which this generative system has to focus. So the first attention mechanisms came about 2014, and then 2017. There was an important paper. It's called "Attention is All You Need," and it uses transformer algorithms, and it's a fascinating system that basically, while generating an answer, it keeps the attention. It doesn't lose the attention of what it's generating, because before it had attention, but it kind of went whatever ways. But in this one, it can keep the focus on what it's talking about. Let's put it that way. Then there were some things like BERT and GPT-3 by 2018. Some other generative models, and especially for images and things like that, in 2021. And then ChatGPT was launched officially to the public in the end of 2022. And it's funny because it's almost like people think like there was a crappy AI before ChatGPT, and now it's like, whoa, AI after ChatGPT. And that's a perception of people. People wouldn't care much or about AI. I mean, an iPhone recognizing your face or something like that wasn't a big deal, right? Or the recommendation system of Netflix is, whoa, it's recommending me the pictures, the movies I like. It's not great thing. But when ChatGPT came out, it's like, not only for people, but these things are doing some very impressive things, so much so that, I mean, it caused optimism and fear. You could see Jeffrey Hinton, one of the fathers of modern AI, the one that came up with the convolutional neural network, like saying this was going to be the end of the human race. What's his name? Harari would also say this is the end of the human race, and so many people, right, saying this was the end of it. So and then this was the end of jobs, and then people in software, people programming, were like, once you give it a try, you're like, dude, is this may put in jeopardy what I'm doing, right? I don't think so, and I'll explain later, but then it definitely caused some concern, and then intellectual property things starting coming out. So that's why I'm saying, before that, no one was really worried about those things. We're maybe talking a little bit about it because technology has always changed jobs, and it's always moved some jobs to something else, and then new jobs can come up and things like that. But in this one, it seemed to be moving really fast. People started, it was adopted really quick. It was more than just a hype of new technology, but it seems to be sinking in really fast in every single field. I had taught, for example, courses for using generative AI, in particular ChatGPT, for people for people that are bank managers, for people that are journalists, people in that have small businesses, people in law, and so on and so forth. And they are already finding ways of using it in their work without asking anyone if they are allowed to use it or not, because they are finding ways that makes them use this tool in a really interesting ways. And I'll talk a little bit about that. But maybe if you ask at the question part, you can ask some more details about those examples. But we'll talk mostly on more computational sort of examples that I have done on my own. And well, then ChatGPT end of 2022, it was a cause of concern. I started using it right away and trying it out. It was fascinating. And well, it has been more than a year of ChatGPT. ChatGPT started pushed, right? It's the idea of, instead of push, it was pulling the ones that are staying behind, and I presume they saw it as an opportunity. They had to come out first and strong. And after this, immediately everyone started creating different large language models and generative AI platforms, right? Google had to come up with something, Microsoft had to come up with something, Facebook had to come up with something. IBM, I don't know what it's doing, but it didn't come up with something, I guess. And some other people, right? And so it's definitely, it was ChatGPT that the ones that kind of started this sort of cascade of things happening because of this. So how can you think about what some generative system like ChatGPT does? If you imagine the following text, you say a computer. In our brains, we immediately think of something next, right? And I call it, it's not a prediction, it's a reasonable continuation of what we're thinking. That's what I call it. It's not a prediction, because although we never say the same words, and perhaps if some of you are more into poetry, maybe you would think something different when I say a computer. If I'm in electronics, I would think differently, and if I'm in computer science, I would think different, and so on. So, but then we give it a reasonable continuation. It's not a random or more probable answer. It's a reasonable continuation, which is a different concept, I would say, in the sense that it's very context. It depends on the context at which you're referring to this phrase in particular, and then it would have a reasonable continuation based on that context. And that's what basically we would, as human, normally do, right? We just think of something, and then as I'm giving this talk, I don't have a teleprompter or something like that, right? Saying or where I have written the words that I'm going to say. I'm thinking them in real time, and even my native language is Spanish, so maybe I'm doing some sort of creepy or freaky translation thing that I don't know what it is. Maybe I'm kind of speaking in Spanish, but maybe rewording, and I don't know what's going on. But then basically, it's not that I have it pre-prepared. It's just that in real time, I'm constructing, right, an answer. And basically, that's what the computer is doing now. And in almost the same way, that's why this idea of attention, this algorithm that it's called attention is all you need, it's basically when I'm phrasing an answer, I'm keeping the attention in the subject that it's really being talked, right? I don't move like somewhere else and do some maybe grammatically correct answer, but it's gibberish. It doesn't mean anything in terms of what we're talking. And that's what these generative systems are doing really well. They answer in a very focused manner, in a very precise way of what you mean. And if your prompt or what you write in these systems is also precise and it's well written and so on, then it will give you even a better answer, right? Because it has more focus, it has more elements by which the system can have attention and then focus. It's sort of, I'm not going to go to the details, mathematical details, although they're fascinating. Basically, your petition, your prompt, it's not read as text. It's basically transformed into a numerical representation of an expression, and these the number represent the uniqueness of the word, but also the relation of that word with every single other word, and then all the multi-headed possible attention, meaning that this word can be related to other words in certain meanings, but it can be related to other words in some other meanings, and so on and so forth. So it creates a hyperdimensional number that then when it's processed, it kind of moves what you're asking to a specific area of a hyperdimensional space, and all the possible answers or the reasonable answers are within that domain. So basically, when you prompt, you're kind of moving yourself to a particular area of a knowledge space, let's put it that way, and that's why it answers within that sort of system. So, and it uses a neural network that it's processed over and over again in order to, every word is creating, it's being fed to this neural network. So then it creates and then computer, and so on, and then it's fed over and over again in order to create the answer. So it's doing lots and lots and lots of computations to be able to do this. So it's something that wouldn't run in a normal computer. We're basically using it, and as I've read somewhere, although I haven't seen a formal number, it costs about $1 million per day just to run the computers that are running all these this GPT from behind. So every time you use ChatGPT, it's doing massive computations in order to give you an answer. And that's what you see, that the words are sort of appearing one by one. It's not some sort of simulation to get a feeling that somebody's writing. It's actually the computation. You're looking at the computation being done in real time, right? The word that is showing up, it's a computation that's been doing in real time. So now what I think it's interesting about this, of these generative systems, is that we used to think of artificial intelligence something that, for example, a company decides to use AI, then you would have to sort of adapt what you do to this AI system, right? So it was bounded, and you would have to kind of modify what you do now to incorporate this AI system. And I think these generative systems are different in the sense that they can be very individual based, in the sense that if I can use it, even people in the same organization, I can use it one way, and then my partner or somebody else in the company can be using it in a very different way. And we're using the same platform, however, we're actually making this artificial system accommodate what we do, not the other way around. And I think that's an important distinction, and that's why it became so popular, because it would adapt easily to whatever you're doing without you having to change very much of what you do. But basically, you say, well, now I have an assistant, and I can do things faster. I can do things more with a more divergence before I converge to something that it's more interesting, and all those things. And that's why I think when it was released, it became massive really quick, and it has been adopted like no other platform at this point had been adopted so fast, like something like ChatGPT, and then other platforms later. Of course, I'm talking mostly about ChatGPT, but I mean, in general, any sort of generative system. Although Gemini and well, Google was called Bard before, and then Gemini, and so on and so forth. But you can use them all. And Copilot is the one that it's Microsoft, which is basically the same, basically ChatGPT behind. So what does this all mean in terms of software development and software in general? And I would borrow something that I see. I saw a very interesting talk about from Peter Norvig. I think he's the head of software development in Google, and he was talking about programming generative AI. And if you think about it, that's why I mentioned at the beginning I was programming a Sinclair ZX81 in the 80s. And when programming or software development, if you think about it, in the 70s, you were actually programming machines more than programming for an end user. So basically, you did a lot of programming at very low level. You had to specify directives that would optimize hardware, and not so much so programming for people as such. So even when the first spreadsheet came out, which was called VC Calc or something like that, it was more focused on what computations can be done in a computer in with something like a matrix as an input, more than what really optimizing a user using it. It was actually I actually used VisiCalc. Of course, I was about 11 or 12 years old or something like that. My dad had it in a computer, and I would do some calculations for him, and it was a pain in the butt. I mean, no one wants to go back to those days. Like, the old days are not better, for sure. I can tell you that. And I can see some people's faces here that probably agree with me, that they know what was that system. The other thing is that most of the problems I call it primitive problems that were really low level sort of problems. So then that's why you would need to program in some sort of low level language. And then it was more individual, like a person would be programming, not a group of programmers. It would be a person or a small group of people actually programming things, not large groups of people like you're doing this now. Now in the 2000s, things were very different. Like, operative systems were everything was graphic, everything was visual. We would program in high-level languages, and most of the programming, I don't think any software company really goes into low-level programming, except if they have to really optimize something that it's hardware, that's becoming a hardware problem. But it's very unreasonable to go low level at this point of life, especially producing software. I remember when I did my master thesis, I programmed some cellular automata, which is some sort of mathematical model, and I used a language called Delphi or Delphi. I don't know how to pronounce it in English. It was basically object-oriented Pascal. But then, since I was doing so many calculations, and we're talking about 2000, maybe 1999, we should put it like it's 1999, like the song. No, it was 1999. I was doing my master thesis, and there were things that were kind of slow. In the computer, it was it must have been Windows 98 or something like that, probably, and then I would have to go low level because it was too slow for me. But nowadays, that doesn't really happen. Machines are so fast and have so much memory that even if you do crappy programming, it's fast enough for most of the applications for software, except if you're doing really analytical stuff and doing some things that are scientific or things like that. So then, basically, programming would optimize programming as such, and we would, because of that, because we were working in a higher level of abstraction, we would then work in more complex problems that involve users, involve machines, involve so many other things. And programming would become something of groups, right? You would have groups of people doing the coding, the programming for certain software. And now it's 220 something, and it seems to be that we're moving to a higher level of language. So this is actually the natural language. So we are almost at the point we can programming using natural language, because we're optimizing actually user. We're not, and even ourselves as programmers, as I'm not a programmer, but a programmer as a user of programming, not so many other things. And the problems that we tackle are actually not even more than complex, in the sense that they're called wicked, in the sense that they're like odd. They may not have a direct mathematical formulation. They have odd patterns. They have things that are not so repetitive, so easy to then reformulate in a more compact way. And we still work in groups. And I focus on these three things that are important. Now we can work with, because we're working in a higher level language, even natural language, we can actually tackle problems that are odd. Let's put it that way. So then, when we think of software, we can even think of things that I think are much more interesting than just what we're usually doing. And we can think of the intention of the user, and not just me trying to tell the user what to do, but the actual intention of the user being incorporated in software development. So if you look at something like this, I don't know you guys, I love programming, but I understand this one way better and faster than this one, right? I mean, this is in natural language. For a number, if the number is even, then divide by 2, and the number if the number is odd, then multiply by 3, and then some 1. This is the same thing, and this thing is Lisp. a functional programming language that uses even prefix notation for the arithmetic. And but if we're talking in a group of people, everyone would have to be an expert in Lisp to understand on this. Well, maybe not an expert, but no Lisp to understand this thing. But if we're talking a group of people, I don't have to teach anyone, not anything, to be able to understand this, right? And from this to this, with a system like ChatGPT, it's just write the one on your right, and then it will create this one in whatever language you want, and then you execute it in a computer. So, it's just a one-to-one relation, even though it may create variations and also. Well, it creates a code that works, and it does exactly what you tell them what to do. In even a more natural, or say, terrestrial example, because I don't think any of you know how to program Lisp. Probably, it's a wonderful programming language. It's a functional programming language. Anyway, but then this is Python. And I mean, if you look at before looking at this part, if you look at this, dude, give me a break. It's a headache to understand this. And so imagine if you have thousands and thousands of lines of code and you have to go through this. This is definitely a pain in the butt. This is not done for humans. This is not for humans. Although it's a formal language and we can work with formal language, we're definitely better working with natural language. And not only that, it's natural language is a lot more universal. Because I mean, I don't have to teach anyone else to speak in a natural language to explain them something, but I would have to explain them how Python works to explain them this, or they would have to have some knowledge of formal languages to be able to do something like this. And this is basically doing a ray casting, what it's called a ray casting algorithm, to be able to tell if a point is within a polygon. And here it's just described as a bunch of arguments that are given as inputs, then a return value that it has to be fed, and then some example of why the example is important, because it gives you a test case, right? So what you expect given a certain test. And that's important. The testing becomes really important, because it's not just put this and then plug it in whatever software you're doing, but you have to test this piece of code to make sure it's doing what it's supposed to be doing. And that's really important. So the important thing here is, when we used to program, we would go sort of, or the machine would do the following thing. You would program in a high level language. There would be some interpreter in case of some languages, or there would be some assembly language created, and then it would be some machine code created, and then some operations would be done in hardware. And that's the usual way a language would be processed. So then we would program basically at this, because all these levels of abstractions were ready for us. In the old days, basically, this is kind of if you look at this way, it's actually it shows you chronologically how computers have been. Right, the first time we worked with computers, were actually mechanical computers. So it was a hardware problem that we were working with. The programming was actually modifying hardware. Then, when the first digital computers, we were actually programming directly using machine code, like directly programming a machine code. Then we used some sort of a bit higher language that would help us with the machine code. It's called assembly, and so on and so forth. And then, well, nowadays I say, well, there is some natural language that we can use to program. There is some large language model that allows us to move it in this direction to other languages. And that's the advantage of doing this. This allows us to specify a lot more the what instead of the how. We're more closer to the what using this than this side over here. This is purely technical, and this has to do with the intention of what I'm trying to do. And I invite you to read something about intentional programming that Charles Simonyi, the one that created Office for Microsoft. He came up with the idea of doing intentional programming that it's really close to what we're being able to do now using large language models. So perhaps programming, it's going to become intentional, where what I want to do, it's a lot more important than just how I want to do it. So what can I do with the generative AI in terms of programming? Debugging, it's really useful for the debugging. Generate assisted code, meaning that you can say, for example, I need an algorithm for raycasting, and then it creates the algorithm. So that's easy and that's helpful. To test code quality, you can specify some restrictions that some code should have, and then you can verify later if those restrictions are met, and it's done automatically, not by a person. Generating code as such, right? Figuring out a problem you want to solve and ask the computer to generate code. This is has I have done several examples and it works really well. Translating code from one language to another, it works really well. I mean, don't give it thousands of lines of code to do it, but if you focus on functions, for example, it gives it makes a good translation, and then to find answers for about certain things in coding that you normally wouldn't. So, for example, I taught a course in algorithms for a master's degree, and then when I was that was the end of last the end of no, the first semester of 20, no, yeah, the last of n years, the 2022, last semester of 2022. And then when I was going to teach it, I looked at for the algorithms book, and it was the same book that I used when I was doing my master's degree. Exactly the same book, a 2023 edition. But when I look at the examples that I had for programming, for example, for dynamic programming, it was exactly the same algorithms. So basically, the book was teaching the same algorithms because they were important, because they're really good for teaching, and so on and so forth. But then we have moved on so far from there. So then if I looked with generative, I ask, well, can you give me a list of 100 algorithms that use dynamic programming that are out there? And it gave me a really long list of algorithms. So with students, what I did was I focused, instead of looking at these kind of algorithms that always work, let's look at some more complex algorithm. And I want you to generate code of any of these algorithms and test them. So basically, the course became a testing ground for different algorithms. They wouldn't have to do the coding, but they would have to test it, execution time, and some other things, and how correctness and some other things, and without having to program in class the algorithm, but using a generative system like ChatGPT to generate the say, for example, optimization of Bellman-Ford. Then we just type it. I need an algorithm in Python for Bellman-Ford, and so on and so forth. And they will give them the algorithm with some examples to run. Then we would test with a testing sample, and so on and so forth. So it was really useful, and I think the students were happy with that, because if not, we are stuck with the same examples as usual. They are interesting, but then I think the generative AI, what I'm trying to say is that it allows us to look at something else, that the textbooks in education are bounded, and they have only a small amount of information. So much more has happened in time. To give you another example, that I wrote recently some sort of article for a education journal, and this is what I write in Spanish. And then I asked ChatGPT to improve that, and then correct some of from any sort of typos and things like that. And it gives me something like this, and then I continue to modify. Say, for example, I add this, and I remodify myself the answer that ChatGPT gave me. So it allows me. If you read it, I know there's no time to read it in detail, but if you read it, it keeps the meaning, it keeps the style, it keeps a lot of things that I'm doing, but it improves it substantially, and it makes it a lot clearer. And that's really useful when you're writing something. It's like somebody, an assistant, that it's very good writing, then that helps you checking code. And this is going to be published. This is a sort of AI manifesto that we came up with at Universidad Senfotec. And so it's sort of our statement on what we think of the use of AI, especially in education. And then so all the text, instead of having somebody, although Ignacio helped me change something in the text, but then Ignacio receives something a lot more like almost there, instead of something when I write because I write, like there is no end. Like I start typing and typing and typing and typing, and I don't care if I'm writing right or wrong or whatever. I don't want my ideas to go away, so I start writing, and then this system helps me to organize later in a better writing style what I actually propose in it, but it keeps the meaning and it keeps the ideas exactly as I post them. So, for example, I have also a column in a newspaper here in Costa Rica, a digital newspaper. It took me a long time to do it. I would have to do it sort of on weekends. It would take. I add some coding to this column, and it would take me like 5 hours with writing and coding, and then it takes me about 1 hour because I don't have to. It helps me check the writing, but it helps me generate some of the scripts that I want to use to show. So, for example, this was about using mask and the effect of using mask, and I can generate a base code in JavaScript, in particular p5.js, and from there on I keep on going and then make it nice. And it took me 1 hour. It helps me code generation, code translation. For example, in this one, I wanted to do a more in-depth analysis, not just a visualization. So I asked, okay, now I have this code in JavaScript. I want you to translate this to Python. And then so there in Python, I could do some more analytical stuff with that. And it was really quick debugging and revisions of the text. Another project, it was more data analytics, and it helped me a lot in creating visualizations. I would just tell them, this is the data set. It was actually with hundreds of thousands of data points. I need to create an HTML map of the 30% of the points. Give me a Python code to do it, and then there you go. And I would then just give this to our partners. Also, segmentation, helping with some of the coding to use AI in with the Keras and TensorFlow and all those things, and then it would help me then prepare the scripting for those things, and then also code translation, where I moved from Mathematica, some things that I did in Mathematica to Python, and also some things I did in Python to R, and so on. So move back and forth between different languages with no problem, without having to spend lots of hours. So what do I think a new programmer would look like? I don't know. What I like to think is that these generative system help us to have augmented capacities. Like it's not that it's going to replace us; it's going to augment us. It's going to make us bigger than what we think we are, and that's what is fascinating. And this idea is not even new. It comes from Douglas Engelbart, one of the fathers of computation as well. And the idea that now is, I mean, I can focus on the real thing, and the coding is just something purely technical, but it's the algorithm, the design, the problem solving becomes a lot more important. I can spend a lot more time doing that, and the coding becomes just a final trivial task to do. So then you can work at really high level stuff in the what instead of in the how. You can focus on the what you want to do, and design algorithms, design systems, design solutions that are a lot more interesting. It allows for creative work, lots of creative work. And something that is very important, I think, with this AI system, and that's why we're talking already about the Industry 5.0, is that it's more a collaboration. The machine becomes a system that collaborates with you, not just a passive system, but actually an active system that you work with to create a solution and to create things. And I think the work, it's going to become a lot more analytical than technical. The technical stuff are going to be done by computers and AI systems, and you can focus on the more analytical stuff that I tell you, this ChatGPT and any of these are really far from being smart as such, right? They're actually not that intelligent if you think about it, but they do a great work in the technical aspects. But then that's why we're still really, really important part of the equation, no matter what job we're doing. And something to think about is that, and this comes from, and this is the last thing, when Kasparov lost to Deep Blue in 1996, I think it was, or 1997, one of those years, he was hurt, right? He was deeply hurt. So then he created what he called the Centaur a tournament, and basically it was a hybrid chess tournament in which computers can have a match with another computer. A human can have a match with a computer, a human against human, or human plus computer against any of the others. And curiously enough, it's always the computer plus the human that wins, because we are really good at creating thinking in other ways and then leaving computers to do the mechanical stuff that can do really, really fast. And that's why I think it's going to amplify. It's an opportunity for people to now look for other ways of broadening your mind. And then now you have a system that allows you to get there really, really fast. So I think we're now super creators, and that's what it's important, and it's an opportunity for all of us now to become really, really good and do things we wanted to do, but because of time we didn't do. Now we can do things fast, that it's the purely technical kind of repetitive stuff. We can do it really fast and now spend hours doing things that are more creative. A friend of mine who's a journalist, I gave them a course using a chat GPT, and he said he would write 5 articles per day, but now he can write 30 articles per day. But those 30 articles are not for publishing them all, but it's just to test things that he have thought, to new ways of writing, new ideas, explore something he always wanted to write an article, but nobody asked him to do, and that kind of thing. So he has lots. He can write whatever is required for the publication, but then he can write 25 more things that are interesting to him, and they're left there. Perhaps someday they will be published. So I went over time. My goal was 45 minutes. I went almost 50. So there is, I think, space anyhow for questions. So I don't know who's gonna. Or should I look at who has their hands raised or something? Jeffrey, I think Jeffrey has a question.
Thank you, Thomas. I have a question. I think you made a big emphasis on how generative AI now allows for a broader spectrum of answers and problem solving, right? But this arises another problem, right? How do we limit how the AI behaves, or what kind of answers does it provide if it's too general, right? I remember cases of, for example, I think it was General Motors, right? I can remember which one had an assistant created with ChatGPT, and it suggested that the person that was asking questions buy a Tesla, right? Because the description of the car the person was providing led to the logical answer of what you need is an electric car, right?
Yeah.
What do you think is the easiest way to approach this kind of problems?
That's a very good question. And what I found out is that it doesn't work that you don't have to be an expert anymore to use these things. Actually, I think it's quite the contrary. You get good results when you're a top expert of something, because you can really narrow down what exactly you need, and you can focus on the domain of information that you're actually looking for, and you know what to do. It's just that you want it to do faster with the system. So you're not asking the system to solve something you don't know what to do. And that's very important. That's a very important distinction. And it shows you that this artificial intelligence, it cannot be an expert or anything. You still are the expert, because you're the one driven the solution using a system that assists you in building the solution. So it doesn't, if anything, it makes you need people that are a lot more expert now, and they can focus on interesting solutions. Now they're just assisted. So it doesn't substitute, basically what you're saying, it doesn't substitute a person that would be the qualified person to come up with something like that, right? That would know how to narrow down and to ask the proper question. And ask exactly what I want, because it's not for me to be lazy and not do anything. It's actually to improve what I do. If you were lazy just to want to replace what you do, it's going to do a poor job. I can guarantee you that. It does a very poor job on things that you don't know what you're doing, and then you just copy paste the answer or something like that. It does a poor job. So thank you, Jeffrey, for the question. Now I have Esteban.
Hi. So it seems to me from what I've heard so far that prompts are very important. Like how do you write a prompt really maximizes your results. So I was wondering if there are any tips you can provide to us as to what would be good things to look in how you write prompts. Like
that's a very good question. And it's indeed that's something very interesting, because it's now I gave a talk to people in for high school. It was the advisors for education here in Costa Rica. And I told them, if anything, these systems are going to force people to be better at writing in natural language, because you have to be precise on what you do. You have to give context. You have to focus on exactly you're asking, what exactly the output you're expecting, what you don't want, what you really want. And then, so it has to be just as if you were working with people and you're managing a group of programmers. You have to be really precise on what directions you need to follow in order to build something. It's exactly like that with ChatGPT. You have to be very precise. I don't have a particular tip, though I would have tips, but it would take too long. But the thing is, you have to be very, very precise. You have to give the appropriate context in order to get a good solution. For example, sometimes what I do is if I'm going to sort of, I want to program something that has to be an epidemiological model, I give them a bunch of models that have been done before as a context. Say, I read this, and then based on that, now I ask the question and say, I need a program, considering that information, I need a program that is bounded by the models that I just gave you, and so on and so forth. So I don't ask for an epidemiological model as such, but I give it very precise, because I know how an epidemiological model works, for example. So then I give it very precise indications that I want a system of differential equations, and I want to use based on an SIR model. But then this IR model, I want to add a term for this, and that, and I want to be normalized, and I want to non-dimensional this to this, and I'm very precise. Meaning, I would do it by hand, but I want a computer by doing it. So I have to be very precise in terms of giving instructions, and that's very important. So we have to improve. One of the things, prompt engineering is becoming a field because of that, right? Because I want the system to give me. If I want to these foundational models, I have to be very precise. And if I want an answer that is consistent every time I ask, then I have to be very engineer exactly how I'm going to ask the question. And there are some tips I can give Ivan later a sheet of tips that I have. It depends on the context of what you're working with. It may vary. Now, Maria Fernanda. Thank you, Esteban, for the question.
Yeah, I have a question. Usually these large language models have some sort of bias depending on the information they were trained on. Is there a way we can formulate something like the request, like the prompt, to mitigate this bias, or is there a way we as users can mitigate the bias?
That's a very good question, and it does have indeed biases. For example, in all the images that I use here are done by AI, in DALL-E specific. If you know that there are a lot of women in the images. If I don't ask specifically that I want a woman programming, it will give me just man. Why? Because if I ask for an image of the 50s, and which relates to computing or engineering or things like that, then in the 50, most of pictures are of men. So then you have to force the system. It would give you a bias, but then you can force the system, force the system to give you something that it's a lot less biased, and you have to be specific in that, saying, I don't want this, I want to do this and way, I want you to include this and that, and so on and so forth. So basically, you again, I go back and you need to know what you're doing in order to overcome, and don't expect the system to give you unbiased answers just on its own. You have to push it to give you an answer that is a lot more inclusive, or a lot more, it involves more domains, or it has a broader context or a better context. Something happened with Gemini not so long ago, that they released to the public their image generator, and then somebody asked for pictures of soldiers, Nazi soldiers in 1943, and it would give Nazi soldiers women, it will give Nazi soldiers people, black people, Chinese people, Indian American people, and dressed as Nazi soldiers. So the thing is that it's really interesting is these systems cannot be forced in that way to be unbiased, because then they sort of because they don't have a context of history or anything like that. It's ourselves that have to be to help the system, or to push the narrative, the discourse, the context to be unbiased, or to include some other areas that historically have not been included. So that's a very good question, and it's indeed as I said, the experts still us in terms of the judgments at the end of what this system is giving, it's correct or not. Luis Diego, thank. I forgot the name. It was Maria, I think, Maria Fernanda, who asked that question.
Hi. My question is very specific, but I don't know if you know about AlphaZero. That is a program that was developed to against very complex games like chess and Go, but it's like a very different, like the classical organism, like Stockfish, that is the most popular now, like Deep Blue. I know.
Yeah, well, that's a good question too. Like Deep Blue was more like I would say like an expert system that they were fed all the, all the chessboards that have been played in history. So it knew all possibilities that have been already played. So it was really bad in the sense of creating something that it's new or different from which it already was trained. AlphaGo was more, they taught him or the system to learn to play Go, instead of just giving them boards and boards and boards of game. So that was very different, and that was an important distinction, because that was what made it possible to, in one of the games, that it made a move that was unreasonable in terms of the expertise of Go, and it confused the opponent, and that was the way it managed to win. And the other thing that came out of this is now there are some systems that mix the large language models generative system with symbolic neural networks, trying to find a solution to problems, but then constructing a logic argument that it's irrefutable in terms of logic. And that's very important too. That allows us, it's very much like us in the sense that we first kind of sketch a solution in a natural language kind of way, and then we try to put it in a more formal way to try to make sure it's correct. And then that came out also from what was learned from AlphaGo and other systems like that.
Well, thank you very much, Tomás, to have given us this opportunity to listen to you today. We really appreciate what you have done, and your presentation will influence a lot of people in this room. We have exhausted our time, and again, we appreciate you to be with us today, and also we appreciate all the audience that we have had today. I know everybody has been very busy, have taken the time to come and join us. Two invites. First, if you are interested in improving your efficiency and quality of your code, right now, please join the GitHub Copilot program that is published in the Gapster Hub AI page. And also, you're invited to our next webinar tomorrow, titled Timing Large Language Models with LangChain, tomorrow at 2 p.m. Remember, this webinar is going to be open to external audience, so you can invite your friends. We also want to hear your feedback so that we can keep improving our events. And therefore, you can use all the link that we have added in the chat of this presentation so that you can fill out the form and give us your feedback. Again, Thomas, thank you very much for giving us this time to listen to you. We really appreciate this, and we look forward to hearing you and having additional relationships extended with Senfotech and yourself. So thank you very much, and have a great day, everybody.